Hi everyone, welcome to our next class using YouTube, of course. Now we're going to be talking about Newton's second law today, and this is where we get to do some calculations. Alright, so basically Newton's second law involves acceleration, force and mass. Okay, we're bringing these three elements together. Now if you stop and think about it, if I have a tennis ball which is really light and I have one of those big medicine balls that are weighted, say it's 5 kilos, if I want to push them at the same and have them go off at the same acceleration, I don't have to put much effort into the little tennis ball, but I'd have to push the medicine ball really hard to get it to have the same acceleration as the tennis ball. So this is the idea that Newton's second law brings together. We're looking at acceleration, mass, and force. Okay, now Newton's second law actually states the acceleration of an object is directly proportional to the net force on the object and inversely proportional to the mass. The heavier it is, the more force you need to increase the acceleration, basically. Alright, so acceleration is equal to the force divided by the mass, or quite often it's written as the force is equal to the mass times the acceleration. Okay, let's jump into our first example today. Calculate the net force causing a 5.5 kilogram mass to accelerate at 3.75 meters per second west. Okay, so let's start off by writing down what we've got. So we've got mass, which is equal to 5.5. The acceleration is equal to 3.75. And the force is what we want to find. Alright, so if I take the formula here, F net is equal to M times A. So I'll take my 5.5 and multiply it by 3.75, and that will get me an answer of 20.6 newtons to the west. Okay, remember this is a vector, so we need direction. So I need to include the west, unless I'm just asked for the magnitude. So remember, if a question asks for magnitude, we only want a number. If it doesn't specify magnitude, we must have direction in there as well. Okay. In the notes, you will find there's now a question for you to do. So please pause the video and have a go at the question in your notes. Alright, we're now going to look at combining equations, and this is the part that I find fun. So remember from our equations of motion, the very first equation is V equals U plus AT. Now if we rearrange that for A, we get A equals U minus V divided by T. So that means we can sub in F net equals the mass multiplied by U minus V divided by T. So we're stepping up our formulas a bit here so that we can solve more complex problems. Alright, let's have a go at a problem using this combined formula. So, calculate the final velocity, so we're going to be calculating V, of a 225 kilogram scooter that accelerates for 2 seconds from rest due to a force of 2,430 newtons to the north. Okay, so I've got mass, which is 225, U, which is 0, because we're starting from rest. I've got my F net is equal to 2430, and I've got a time of 2 seconds, and I want to calculate V. Alright, so I'm using my formula. F net is equal to mass U minus V divided by T. But I want to find V, so I'm going to rearrange the formula to give me V is equal to force divided by mass plus U. So I've got, oh, that should be times T in there. I was wondering where my T had gone to. 2430 multiplied by 2 divided by the mass, which is 220, plus nothing. Therefore, my final velocity is going to be 21.6 meters per second, and of course it's to the north. Okay, so I've got my answer there, 21.6 meters per second to the north. Alright, so there's a question for you to have a go at now in the notes, so pause this video and go and do your do now question. Have a go at using this combined formula. All right. Now, the reality is we know that we're not usually dealing with one force, are we? We have things like friction and drag and air resistance, they all come into play. In those kinds of questions where we've got to allow for more than one force that's acting, we need to treat the forces like vectors because they are vectors, so we'll have to add and subtract till we get the overall force that is acting. Alright, let's have a go of a question where we need to actually work out the net force, the overall force, by adding and subtracting our vectors. So we have a swimmer who has a mass of 75 kilograms. He applies a force of 50 newtons as he takes off. But the drag in the water is acting against him, and it's acting against him at a rate of 20 newtons. So what is his initial acceleration? Okay, so the first thing we need to establish is what the net force is. So he takes off with a force of 50 newtons, and let's say he's swimming in the positive direction. The drag is working against him by 20 newtons. So that's minus 20. So overall, I have 50 plus the negative 20 to give me an overall force of 30 newtons. So that now that I've resolved my net force or my overall force, I can now work out the rest. Okay, so I've got acceleration is equal to the net force over the mass. The net force is 30. His mass is 75. So I have an acceleration of 0.40 meters per second, and we're traveling forwards or north or in the positive direction, whichever way you want to look at it. But we do have to indicate forwards or up or into the positive. Alright, Again, if you pause the video, well actually we're pretty much coming to the end of the video, there's a do now question for you to have a go at working out the net force and then using that information in your actual question. Okay, I will see you all online for the WebEx meeting. Do stop the video and go and complete your do now questions. You're going to be working on questions 1 through 10 only from 10.2. We're going to look at connecting bodies in the next lesson. Alright guys, I'll see you then. Bye.